In this part 2 of the podcast, Michael Stonebraker talks about the past, the present, and the future of databases, his company Tamr, Turing Award, and entrepreneurship. So stay tuned. Interesting. And one more thing I want to talk your perspective on. I think you have been very vocal advocate on the so-called NoSQL movement. So what's your take on that? Like, what do you think has happened, and what do you think? What's your take on that movement?
Okay, one of my favorite topics. Thank you for asking. So the NoSQL guys started out life as saying, "Don't use SQL. I have a better option." And so what was their better option? They said, throw away transactions and go back to programming at a low level using record at a time algorithms. Well, we had a big debate in the 70s of low-level stuff versus relational stuff. And everybody agreed that high-level languages are good. And over probably the 1980s, it became crystal clear that high-level languages were good and compilers were good enough that they could produce code that was as good as most people could write at a low level. So never bet against the compiler. Exactly what the NoSQL guys were doing. So I think high-level languages are good. The 40 years worth of history that suggests that. The NoSQL guys, in fact, are correct that the concurrency control and crash recovery stuff used by the big vendors is very slow. The answer to that is to run the new breed of OLTP systems, which don't use any of that stuff, which have different algorithms in them. So I think the two main tenets are of the NoSQL guys. The first tenet is just plain wrong, which is low-level languages are better than high-level languages. The second tenet is they were right, and you want to move to different relational implementations. The third thing they were selling is that you could, in a traditional relational database system, well, you have to create a schema up front. It's schema first. There's a big overhead to getting going. NoSQL guys said, just start loading data. And so the schema later. And what that really means is, let's have JSON as a data type. So you don't have to make an upfront commitment to how things are really going to look. And that was a really good idea. So the NoSQL guys had a good idea, said get rid of concurrency control and recovery because it's too slow, when what you really want is an alternate implementation of that stuff. And then they're just plain wrong on high-level languages. So that was their initial pitch. What quickly evolved was they redefined NoSQL to mean not only SQL. We want to coexist with the SQL guys because their transactional systems actually have a place. There's some people who really want transactions. And in fact, there's a bunch of stories that have been in the popular press about how people hacked. Well, the one I remember is there's a Bitcoin application that was running on Mongo and got hacked by exploiting the absence of transactions, and the intruder swiped a whole bunch of Bitcoins. And so transactions are really a good idea for when you care about your. So it became not only SQL. In my opinion, what the current definition of NoSQL means is not yet SQL. Because, if Mongo and Cassandra have both built high-level languages, which, unless you squint, look exactly like. And Mongo threw away their storage manager and bought storage manager from Wired Tiger, which, guess what, has a good transaction system in it. So I think, and the relational guys are now supporting JSON. So I think NoSQL and SQL are converging into high-level languages are good, transactions are good. JSON is a good idea. Schema later is a good idea. And one size does not fit all. There may be many implementations for various kinds of problems.
Interesting. So I think one thing that
the last thing about NoSQL is that there's about 100 NoSQL vendors, all with totally different interfaces. And that class of systems cannot survive without standards. Relational databases have prospered because there's SQL. It was a standard. And you can train your people on one thing and they can then know it. Unless the NoSQL guys can get behind some standards, they're just going to, I think they're going to be a historical artifact in a few years.
Interesting. So what has been, so you have seen SQL evolve, you have seen the sort of NoSQL movement somehow going away and then coming back in as a supplemental sort of support system to SQL. What would be your prophecy? Like, what do you see, where do you see database further evolve from now and onwards? We'll resume after a short break. This part of the podcast is brought to you by First Friday Fair, fastest AI-powered way to find your next opportunity. Check out the website firstfridayfair.tao.ai and find your next dream job. Let's get back to the podcast.
Okay, so I think a couple of things. Now, number one, I think there's going to be a lot more array databases. So genomics needs array databases. If you look in the medical world, EKGs, EEGs, a lot of medical testing is basically arrays. So I think that market is going to expand. That is not going to be a SQL market now or later. And so that will be a place where the vendors are doing things like array SQL, that look like SQL but run on arrays. So I think I hope that will become a sizable market over time. Second place where I think the world wants to do machine learning. Machine learning models are array based. So that's a second place. And if you're building a machine learning model, first of all, everybody needs to do it at scale. And so currently people are doing it in the small, and doing it in the large is going to require storage management. The way you do machine learning realistically is you construct a model, it doesn't work right, so then you change the parameters, it still doesn't work right. It's an iterative solution. And then you get somewhere and you say, well, I need to back up 10 iterations and try something different. So you basically need a versioning system, kind of a significant storage manager that keeps track of all this stuff. And that will be array-based, presumably. The other place this is going to be another big deal, which is if you look at what Tamr does, one of the things Tamr does when it does data integration is data cleaning. The problem is the way, and Tamr has a few hundred customers, all of whom have to do data cleaning in the process of doing data integration. Well, the trouble is there's never ground truth, never. I've never seen ground truth. And so, what you have is and so if you say, is Staples Incorporated the same thing as Staples Company? One is in Cambridge and one is in New York. Well, who knows? You make your best guess. Ground truth is too expensive to come by, because you'd have to send people out to actually look. Or if I have two different restaurants at the same address, is this a food court, or did one replace the other, or is it a data error? Again, ground truth is elusive. So what every Tamer customer does is cleans for a while, and you clean the important data, and then you say, let's see if we can make our stuff work. And then you try it, and it either does or doesn't work well enough. If it doesn't work well enough, you've got to go back and clean some more. And so cleaning and modeling is an iterative process. Modeling and adjusting parameters is an iterative process. All of this is a big iteration over data cleaning plus parameter tuning plus machine learning models. And the support for that stuff, I think there's another big opportunity for database technology. A third great opportunity is that if you look at the cloud, well, all the current database systems, almost without exception, you basically deploy your database system on 17 servers attached to 32 disks, and that's static. And if you want to deploy it on 20 servers, well, then you have to rip everything down and reload it. On the cloud, at least Amazon is essentially forcing you to use S3. S3 is a distributed file system. It's not a partition store, which is what all the data warehouse vendors are expecting. Well, Amazon supports a partition store, but their charging system makes it wildly expensive. So everybody's effectively forced to use a distributed file system, which says that you can decouple computing from storage. So that means you run a query, it can be on 20 processors. I run the next one, I only need 3. You can do resource allocation at much finer granularity. Well, the S3 requires you to change a lot of stuff. And dynamic resource allocation requires you to change a lot more stuff. So getting a database system to work well on the cloud, is an ongoing issue. So I think that's going to keep the vendors busy for a while.
Interesting. So I think cloud. I think I definitely want your perspective on. So data has been very close to its owner for quite some time. So my server is right in my basement somehow. I'll keep the data here. Now this revolution comes where the cloud services came, and then we start seeing on-prem and off-prem. What's your take on the mobility in data? Right. So right now it's do you think it will come back to my basement at some point, or do you think this will be on the cloud for a while? What's your take on that?
It's going to be on the cloud forever. And it's going to be there because it's cheaper. It's going to be a great deal cheaper. So James Hamilton is, a very, very smart guy who works for Amazon. And he claims, and I have no reason to dispute his claim, that he can stand up a server at 25% of your cost. And the reason is just scale. And, if you're running servers by the millions, It's just a different ballgame than if you're running servers by the threesies. The claim is that the claim is often made that security, that your enterprise security is better than Amazon's. And I think that's just totally false. That if you look at who gets data breaches, it's you, it's not Amazon. Well, data breaches do happen at Amazon. Amazon, who's running servers by the millions, really cares more about security than you do. And they have smarter security people who are focused on security. So if you look at where the breaches occur, it's mostly misconfiguration of your servers. And that's because you either don't have rocket science talent worried about this, or it's just not that important by the threesies. The other place breaches occur is that it's a human basically swipes the data, and that will happen no matter what. So I think Amazon security is better than yours. I think the argument is often made that regulatory agencies require my data to be on-prem. I think that will change fairly rapidly, although I think it will change because technically the right answer is to put it off-prem, and regulatory agencies will catch up. Regulatory agencies also say your data has to be in the U.S. It can't be in Mexico. And I think all the big cloud guys have servers all over everywhere and are happy to deploy according to whatever your restrictions are. So I think the cloud guys will just totally take over.
Interesting.
And I think if you think about things, if you want to run, well, I mean, the Tamr guys face this all the time. There's a new project, so I want to try a pilot of putting this together with that. Well, if you're going to do it on-prem, you need a machine. So how do you get a machine? Well, you requisition one from IT. Well, how long does that take? 3 months. On the other hand, if you want to try a pilot of connecting this to that, you give your credit card to Amazon and you're off and running. And so I think ease of deployment, flexibility of deployment, the fact that you can do resource allocation on the fly, those are all powerful reasons to use the cloud.
Interesting.
Not to mention that if you put your machine in your basement and there's a flood, then you're toast. Yes. And Amazon won't do that.
Interesting. No, I think that's a fair point. Now let's spend a few minutes on Tamr, right? So I think one thing that was fascinating was, so if you look at your journey, right? So you were pretty much on the database end. You're trying to figure out the schemas and how to optimize it for an enterprise world. And now if you look at the Tamr, it's pretty much like in a management solution side of things where AI is involved. Like, what made you shift in the direction of Tamr? Like what induced that change? We'll resume after a short break. This part of the podcast is brought to you by First Friday Fair, fastest AI-powered way to find your next opportunity. Check out the website firstfridayfair.tao.ai and find your next dream job. Let's get back to the podcast.
Okay, so it's actually been a long journey. In the 1980s, I built a system called distributed INGRES, which is, I said, well, the problem is you got some data in London, you got some data in New York, you got some data in Hong Kong. What you need is a distributed database system that will allow you to run queries across the data in all three places. So we built distributed INGRES, and nobody wanted it. and nobody wanted it because the schemas weren't the same at these three places, and you couldn't, the federated database systems didn't have, couldn't cope with the fact that the schemas were different. So that was the first problem. The second problem is you say, well, if the schemas aren't the same, well, imagine you're the human resources guy in Paris and I'm the human resources guy in New York. You have employees, I have employees. Your employees have salaries, my employees have salaries. Your salaries are in euros, net after taxes with a lunch allowance. My salaries are gross US dollars, no lunch allowance. So the conversion between those is non-trivial. So I said, maybe the problem is that these guys are stuck on data conversion because it's a mess. So we wrote a system, at MIT called Morpheus that made it really easy to do transformation. And what happened was nobody wanted that thing either. Because that wasn't the problem. The problem was the data was dirty. You needed to remove duplicates, which is not a transformation problem. And you needed to do this stuff at scale. So that caused me to say, gee, the problem is data unification. It's not data transformation, and it's not federated databases. So we built a prototype at MIT called Data Tamer. And while we were building this, we got approached by 3 different enterprises saying, that's exactly the problem I want solved. So that was so then I said, gee, there's probably something here. And so that was the genesis of the Tamer Corporation, was solve the data unification problem as it was exhibited by the early prototype users of this thing called Data Tamer. And so that's where Tamer came from. And the thing that I found fascinating was, if you look at the database world, so I built a number of database systems. It's really hard to get customer number 1. Really hard to get the first half dozen customers. Because they all say, rightfully so, your software is very immature. It's going to have bugs. It's going to crash. Come back when you're on version 4. So it took Vertica, which was the column store company, probably 3 years to get a reliable enough product that people would pick it up and put it in production. With Tamer, in year 1, we had production customers putting what I would call pre-alpha code into production because they were in so much pain. And so the pain level of data unification is just really extreme. And so the Tamer journey has been, General Electric became an early customer. When our product was extremely unreliable and held together by chewing gum and baling wire. But their problem was they have 75 procurement systems. Now, the procurement system is, you want to buy some paper clips. You go to your procurement system, you give it accounts and stuff, it spits out a purchase order, you take it down to Staples, and you get your paper clips. The ideal number of procurement systems in a corporation is 1. GE has 75. The CFO of GE figured out that if you're one of the 75 procurement guys or women, your contract comes up for renewal with Staples. If you can figure out the terms and conditions negotiated by the other 74, your other 74 counterparts, and then just demand most favored nation status. That's worth $100 million a year to GE. But to do that, you've got to unify 75 independent supplier databases. And so, but the upside to being able to solve this problem is huge. And so supplier mastering, if you want to call it that, Toyota Motors has customer mastering. Another Tamr customer is Carnival Cruise Lines, the guys with the big white boats. Carnival Cruise Lines is in fact an amalgamation of 9 different original cruise lines. So Holland America is a Carnival company. Carnival is a Carnival company. It turns out in Europe there's some other company whose name temporarily escapes me. So anyway, there's 9 different kinds of boats that all are owned by Carnival. Well, they all use the same straws in their dining room. So Carnival wants to, the gleam in their eye is to share parts. So right now, every boat has spare parts on the boat, more spare parts on the dock, more spare parts, in the warehouse, times 9 or times 20. And so they want to unify all of this stuff. But to do that, they've got to do parts mastering. And so Holland America says, we use latex gloves. Carnival says we use rubber hand protectors. And so it's same problem trying to master parts. It turns out lots of people, customer mastering, parts mastering, supplier mastering. It turns out the big pharma wants to do, wants to do drug mastering. So what that means is Novartis, for example, has about 10,000 chemists and biologists doing wet chemistry and biology. So they're basically taking in some gook and producing other gook and writing down their results in lab notebooks. So Novartis wants to integrate 10,000 lab notebooks because if you're in Basel, Switzerland, and you're producing gook X, I might be in Cambridge producing the same gook by different means, and they want to do this for social networking purposes over times 10,000. And what they want to do is gook mastering or drug mastering. So practically everybody on the planet wants to do this stuff, and every enterprise is siloed into business units so they can get stuff done. And that's not going to change, because if you don't do that, then you have to ask the CEO every time you want to turn around. So
interesting.
So the idea is to be able to do cost-effective mastering, cost-effective data unification, and the upside to being able to do this is huge. And the answer is, what's different today? The answer is you can apply machine learning. So apply ML and statistics, which is exactly what Tamr does.
Interesting. And I think you have been a serial entrepreneur for quite some time. Like, you have been running some great industries, companies. In your experience, what are the ingredient of a successful startup? Like, what do you look for so when you roll out, say, Tamr, what is that aha moment that you say, okay, this is bigger than this would be fun to do? What are some of your litmus test on that?
Okay, so I think the number one pitfall is you've got to be ruthlessly focused on the smallest possible market. And so I see lots of companies that get distracted by trying to solve too big a problem. And so, back in the database world, it costs about $30 million to get a production database system really working. And you've got to stay ruthlessly focused with milestones so that you deliver something in the first 3 million so that the VCs will put up more money. And so people wildly underestimate how difficult it is to build product. And so I think the answer is be ruthlessly focused and create, construct milestones and then meet the milestones. And I think there isn't any rocket science here. You just have to do excellent project management. And what that really means is to have your founder have enough experience that you don't overextend yourself. So I think that's number one, is to run out of money before you have a product, or before you have a milestone to run out of money. And then, of course, you're dead. The second thing, which I think is another huge problem, is to, and I am guilty of doing this more than once, which is to attack a market that doesn't exist. And so we built a federated database system in the 90s as a we commercialized a Berkeley prototype. But we talked earlier, there really isn't any market for federated database systems. And so you're toast before you even start, because so you have to make sure there's a market. And the obvious way to do that is to go find 2 or 3 what are called lighthouse customers, who will say, if you build this, I'll buy it. Or put differently, to make sure that you build a product that somebody wants rather than one that nobody wants. So make sure the rubber meets the road rather than the sky, by very early on getting lighthouse customers as early as possible. And then the other error people make is, once you have a product and you have a couple lighthouse customers, then you hire a VP of sales, you hire a VP of marketing, you hire 5 sales guys, and you basically beef up on the sales organization. And the trouble with doing that is it takes a sales team 6 months to get productive, and then run out of money from paying the sales guys. So kiss every nickel. And, you need one business executive in a startup, and he is your salesman for the first 5 customers, and don't hire anybody else. So the ideal startup team is a bunch of engineers and 1 executive. No administrative assistant, nobody, no front desk, no one sitting at the front desk. Make your own travel arrangements. There's no one doing that. So basically, 5 engineers and a business person. Hire nobody else until you're sure that you have something that somebody will buy, and that you can get it to where either there are milestones for the VCs to put in more money, or there are customers that will actually pay you for it. So run lean and mean, leaner than you can ever imagine, because startups go out of business when they run out of money. That's the only way. That's the only way they fail.
We'll resume after a short break. This part of the podcast is brought to you by First Friday Fair, fastest AI-powered way to find your next opportunity. Check out the website firstfridayfair.tao.ai and find your next dream job. Let's get back to the podcast. That's very, very good point. And let's talk about your Turing Award.
And then the other thing about startups, do not under any circumstances rent Class A space. Get space, Class C space, or maybe B space. go to Office Depot to get your furniture, get used furniture from somebody else who went out of business. I mean, spend no money. I just can't overemphasize how important it is to spend no money.
That's a very good point. Yeah. Thank you for sharing that, Mike. So let's talk about your Turing Award. First, congratulations. That's a huge achievement. What led to that?
Well, I think it's every researcher's secret fantasy to win the Turing Award.
Yeah,
including mine. And the favorite story my wife loves to tell is that the Turing Award winner is announced in March of every year. And so March would come and go, and I wouldn't get a phone call saying I won, and I would be really depressed.
Oh my goodness.
And so she would say, March is a terrible month. And so when you win, it's totally out of thin air. It's just like the Nobel Prize. You get a call saying you won, and all of a sudden everything's different. Because I guess my goal in life had always been to win the Turing Award. That I always said that's the crowning achievement of success. And when it happens, then there's nothing else to strive for.
So, beautiful. Thank you for that. So now let's spend a few minutes on you, and thank you for being really generous with your time on that. I do appreciate that. So, in your journey, what are some of the tenets, some of the qualities that has really helped you stay successful and sane throughout this evolution? Like, what would you attribute those qualities that has really helped you become what you are today?
Okay, well, I think it's actually pretty simple. At least my point of view. Other people are different. My point of view has always been, there's a gazillion research ideas, and it's sort of, where does the rubber meet the road versus the sky? The answer is when somebody wants what you've got. And so and you've got to talk. It's a lot of shoe leather to talk to a lot of people to figure out what it is that would provide value for them. They don't talk your language. You've got to figure out, intuit what they want from them talking their language. So the answer is talk to a lot of real world people and listen carefully to what they want. And when the biggest mistakes I've made was when I didn't do that. And so that keeps you on track doing something that somebody actually wants. The rest of it, I think, is I don't know where it comes from. I mean, I think the answer is column stores and main memory databases got started from random encounters with people complaining about performance. And data integration came from doing it wrong several times. You finally get the right mix of stuff. So I think the answer is try stuff, fail fast if you can, and talk to a lot of users. The other piece of advice I would give is that if you're in academia and you're doing database systems, make sure there's somebody else at your university to talk to, because not everybody needs a sounding board. And at MIT, there's several sounding boards, and that really makes for a vibrant community. But make sure there's a sounding board. If you're an assistant professor, make sure that you've got a mentor, because everybody needs help navigating the politics of getting tenure. So make sure that you mentor either at your university or at some other university. And if you don't have a mentor and you don't have a colleague to talk to, go find one at another university and start using that person. So when I first moved to MIT, there was nobody in databases at all. And so there was a database person at Brown, there was a database person at Harvard, there was a database person at Worcester Polytech, there was a database person at Brandeis. We formed sort of a Boston area research community, and that gave us all people to talk to. So form a community that will be a sounding board.
Interesting. And if I need to ask about your favorite book, that I think we ask all of our guests to share their favorite reads, their favorite books that they want to share with our listeners and viewers. What would that book be? Like, what would if you can share your favorite reads?
Oh, sure. I think the most persuasive book I've read recently is called Dark Money. I think it's by Jane Meyer. Scares the absolute crap out of me. And in summary, the conservative people with a lot of money are buying elections, just with money. And any thought that we have one citizen, one vote is dispelled in that book. So that had a huge impact on me, and it's just terrifying.
Interesting. And now, last question, but not the least. So, if you want listeners and viewers to take something away from this conversation, what would that be? Like, what would be your parting thought to our listeners and viewers?
Get smart on database. Database technology is in everybody's future. This notion of big data is there. It's not going to go away. And your ability to make gigantic mistakes, is right up front. So get smart on database technology, because you're either going to buy it, and the cacophony in the vendor marketplace is extreme. So get smart on understanding data management would be my elevator pitch to all of you.
With that, Mike, thank you so much for sitting with us, sharing your perspective with our global listeners and viewers. We are privileged and honored to have you in contributing your context in our conversation. Thank you so much. Wishing you nothing but success. Success to Tamr. I think you also have a book. One of the guests came and he just took the book. I don't have the book to show, but I will put the link on the description, so for our listeners and viewers to take away. Thank you so much also for your time.
The lecture that you get to give when you win the Turing Award, I gave a very offbeat lecture on how Postgres got built. So if you want a lesson on how difficult it is to build system software, just go listen to my Turing Award lecture.
I thank you so much. I'll put that on the description. Thank you so much, Mike. I appreciate your time.
I thought I was sick of home, but actually I was homesick. Never really knew that I would have to grow up so quick. I'm so uncomfortable, don't know anybody here. Just a couple dudes that I met once, that's it. And I go into the booth feeling nervous. Got butterflies in my stomach like I'm so worthless. Is the mic on? I don't know how to work this. Inside I'm breaking down, I hope I'm not up on the